Okay, so we're on problem number 60. Yeah, let's do 68. Let me change it on my notes here. Okay, so what we have is we have a circle, a big circle and two small circles. And we're trying to figure out what is the net area. So let's draw this out. So there's your big circle. Here are your small circles. And I'm just going to have to eyeball it. I probably made them a little small. So let's make them a little bigger now. Okay, so what we're given is that the radius of the inner circle is 4 centimeters. So if we go from here to here, that's 4 centimeters. And so the diameter of the radius of the big circle is going to be 8 centimeters. So if we go from the center to here, let's do it over this way. So that one is going to be 8. So this is the smallest 4. This is 8. So what we're going to have is we're going to have area of the big circle, we'll call it area B, is equal to pi RB squared. And the area of the small circle is going to be pi R small squared. And R big is equal to 8. And we have units of centimeters. R small is equal to 4 centimeters. And so the net area, we'll call it area net, what's left over, is you take the big area and subtract 2 times the small area. Here's the big area, the small area. What's left over is this stuff right there, the shaded area. So that's all we have to do. We just have to plug it in here. So we're going to have pi R big squared minus 2 times pi times R small squared. So we have pi times 8 centimeters squared minus 2 times pi times 4 centimeters squared. And so let's just plug the numbers in, do an R calculator. So we have pi times 8 squared, which is 64, minus 2 times pi times 4 squared, which is 16. And we get 100.5. So we get 100.5 centimeters squared. So that's the net area, the area that's shaded. Okay, the next one is going to be, we're going to go to 70. Skip just 2. The following exercise shows prices actually charged by Ma, Ma's, Gigi's local pizzeria. In each case, the dimensions is the diameter of the pizza. Find the best buy. So what we're going to look for is what is the cost per square inch. And the one with the lowest cost per square inch is going to be the cheapest. And I've actually done this cost per inch squared, or it's cost per basically area, cost per unit area. To see, you know, typically the larger pizzas is lower cost per area. But you never know. You know, somebody could try to fool you. Okay, cheese pizza with 2 toppings. 10-inch pizza sells for $7.99. The 10 is the diameter. So the first option is the diameter equals 10 inches, and the cost is $7.99 for the whole thing. B is a diameter of 12, and the cost is $9.99. And the third case is 14 inches. So the diameter is 14 inches, and the cost is $10.99. I bet that's the best buy. So what we're doing is cost per area. So all we have to do is take the cost, which is $77.99, divided by the area, which for the pizza for a round for a circle is pi d squared. Actually, I'm going to square the whole thing. So it's 10 inches squared divided by 4, which is the same as $7.99 times 4 divided by pi times 10 inches squared. So let's see what we get there. So $7.99 times 4 divided by pi divided by 10 squared, which is 100. So what we get is $0.102 per inch squared. All right? Yeah. Point. So it's like 10 cents per square inch. Okay, so we just do the same thing here. We take $9.99 divided by, let's just put it in this form. So we're going to go ahead and multiply by 4 and divide by pi and multiply by 12 inches squared if you do that. So all I'm going to do is change it to $9.99 on my calculator, change the diameter to 12, and I get point. So I get $0.088 just dollars per inch squared. So it's less, it's cheaper. And then finally we go to the biggest pizza, which is $10.99 divided by, well, times 4 divided by pi times 14 inches quantity squared. So I'm going to change my pizza to, I'm going to insert thing here. $10.99 times 4 divided by pi divided by 14 squared, which is, I think it's 196, but I'm just going to put 14 squared in there. And so I get 0.071. That's dollars per inch squared. So this is like 10 cents per inch squared. This is about 9 cents per inch squared. This is 7. So you can see that that's definitely the best choice is the 14-inch pizza. So that's why compromise. Do you share a pizza with somebody else? Do you get 2 medium pizzas, or do you get a large pizza and split it? And you can work that out. Let's figure out, you know, in terms of the area. You know, is it double the area? Is the large double the medium? If it is, then you're in good shape. Then you can work out the cost per unit area if you wanted to. If you're a real math nerd. Okay, 73. James Garfield proof of the Pythagorean theorem. James A. Garfield, the 20th president, provided a proof of the Pythagorean theorem using the figure at the top of the next column. Supply the required information in each exercise in order to follow his proof. The area of the trapezoid WXYZ using the formula for the area of the trapezoid. Okay, I'm trying to decide what to give this to you guys. I'll just do it in class. That'd be an interesting class problem, so let's just skip that. So we're going to skip 73 and 76, and we're going to do it in class. Okay, so we're going to skip 79. Area of a square. The area of the square PQRS is 1250 square feet. TUVW are the midpoints of PQRS. Okay, what is the area of the square TUV, which is the square in the middle that's kind of like a triangle? or not a triangle, like a diamond. So here's a square. I'm going to make another square, and I'm going to rotate it so it's like that. Move that inside. I'm going to stretch this thing so it just fits. Okay, so there you go. That's pretty much what we have. And so they're saying that this, so since it's a square, let's call this x. So what we have is, we can solve for x because it's a square. So we know that x squared is going to be equal to 1250 because it's just two sides multiplied together. So you take the square root of that, take the square root of 1250, take the positive version, so it's equal to the square root of 1250. So I get x is equal to 1250 to the 0.5 power is 35.355 feet. Okay, now what we want to do is find the area of this square, but probably the best way to do it is to make it into two triangles. So I'm going to take this, break it in half, and this is the height of the triangle, and this is the base. So for the triangle, the base is equal to 35.355 feet, and the height is equal to 1/2 of that, so it's base divided by 2. So if we divide that by 2, divided by 2, we get 17.67. 17.67 feet. So the area of this inside square is going to be 2 times the area of the triangle. So we'll say the inside square is 2 times the triangle we just came up with. So we have 2 times the triangle, which is 1/2 the base, times the height, and so these cancel out. 2 divided by 1/2, 2 divided by 2 is 1, so we take 35.3555 times 17.677, and we get 625 feet squared. And how does that compare? That's half. So the area of the inside square is 1/2 the area of the big square. So that would be one way of doing it. We could have just, I think here, we could have done it symbolically. So let's just do that. So x squared is equal to a. So x is equal to the square root of a. So that's x. And then we could say the base is equal to the square root of a. And the height is equal to 1/2 the square root of a. So if we wanted to find the area of the inside square, it's going to be equal to 2 times the area of the triangles, which is 1/2 the base, which is the square root of a, times the height, which is 1/2 the square root of a. So we end up with these canceling out. You get 1/2 the square root of a times the square root of a, which is a, and you just get a over 2. So that's the other way of kind of keeping it all symbolically. Okay, what do we got next? 82. Perimeter of the polygon. Can the perimeter of the polygon shown be determined from the given information? If so, what is the perimeter? Okay. So the answer is yes, but I don't know why yet. So I haven't thought about this one. I haven't thought about him because I'm just doing it for the first time. Okay, so that's what it kind of looks like in the book. This side is 13 inches. This side is 7 inches. And the question is, what is this length? Oh, interesting. So I'm going to stop this and think about it because it's not coming straight to me. Okay, so the question is the perimeter. That's the thing, is the perimeter. Okay, so we really don't know where this is. But the thing is that, let's say this is x, then this is going to be 13 minus x. And if this is y, then this is going to be 7 minus y. So it really doesn't matter. When we add all these together, whatever the unknowns are, it's going to be, the perimeter is going to be 13, which is this length, plus 7, plus 13 minus x, which is this length, plus y, plus x, which is this length, plus 7 minus y. So that's the perimeter. And so you can see what happens is you have negative x plus y minus y. And so we get 13 plus 7 plus 13 plus 7, and that equals 40. And the units are inches, so the answer is 40 inches. So that's the key, is it doesn't really matter. The perimeter stays the same no matter where this goes. Because I didn't specify x and y, I just said it's x and y. And x can't be greater than 13 and y can't be greater than 7, so it has to have that domain. Okay, 85. Now the area, that wouldn't be kosher. So the area of the quadrilateral, find the area of the quadrilateral if the angles B are right angles. So let's draw that out. So we have this goes to there, which is a right angle to that. That goes over here. And then this is a right angle, like that. So these two are right angles. And we know that this is 2, this is 8, and this is 6. So what we're going to do is we're going to draw a diagonal here, from here to there. So what that allows us to do is it allows us to make two right triangles. And so because these are right triangles, I can figure out the hypotenuse. So let's call this x. And once we know all the dimensions, then we can use the area of a triangle. And the height of this triangle is 6. The height of that triangle is 2. So all we need to do is figure out this base, and then once we get this base, then we can easily do it. So x is equal to, well, x squared is equal to 6 squared plus 8 squared from the Pythagorean theorem. So x squared is equal to 64 plus 36, which is 100. So you take the square root, x equals 10. So that's 10. And then we use the Pythagorean theorem on the second triangle. So what we have is, we'll call this y. So we have y squared plus 2 squared is equal to 10 squared. Y squared is equal to 10 squared minus 2 squared. Y squared is equal to 100 minus 4. Y squared is equal to 96. Y is equal to the square root of 96. And we can change that to what is 96 divided by 36? 96 divided by 36. 6 divided by 36 is 2, so that's not going to work. What we're trying to do is find a complete square. So we'd have 6 times 6, 4 times 4. So let's take 96 divided by 4. That's 24. So that's going to be actually 96 divided by 16. 6. Okay, so you get 16 is 4, square root of 16 is 4, so you get 4 times the square root of 6. That's the reduced version. How do I do that? Well, square root of 96 is the square root of 16 times 6. 96 is 16 times 6. Well, the square root of 16 is 4, so you can bring that outside by taking the square root, and you're left with 4 times the square root of 6. 4 times the square root of 6. So now we have two triangles. Triangle 1 is 1/2 the base, which is 8. And I'll see if there are units here. Given units, no units. Okay. So that's the base. The height is 6. That's the height, perpendicular distance from the base to the opposite corner. Plus 1/2 times the second triangle. The base is 4 times the square root of 6. The height is 2, this distance. So we get 48 divided by 2, which is 24. Here we get 1/2 times 2, which is 1. So we get plus 4 times the square root of 6. And that's the right answer. So that's the area, total area. By adding we change this quadrilateral into two triangles. We use the Pythagorean theorem to find this unknown interior, this diagonal. Then we use the Pythagorean theorem again to get this unknown side, which is the base of this second triangle. And then we found the area of each separate triangle added together. Okay, and the last problem is 88. Area of the pentagon. In the figure, pentagon PQRST is formed by a square and an equilateral triangle such that PQ equals QR is equal to RS equal to ST equal to PT. The perimeter of the pentagon is 80. Find the area of the pentagon. So let's just draw our triangle, or let's draw a pentagon. We get up with a square. So it's a square plus a triangle. Equilateral triangle. So let me put that in there, make sure it's quite equilateral. Okay, so there it is. And I'm going to rotate that like that, attach it. I'm going to rotate it this way. It's not exactly right, but it's close enough to the figure. So that's a pentagon. Pentagon is 5 sides. And this is X, and this is X, and this is X, and this is X, and this is X. So the perimeter is equal to 5X, which is equal to 80. So the length of each side is going to be equal to 80 divided by 5, which is 16, I think. 80 divided by 5 is 16. Okay, so now what we're going to do is we're find the area of the pentagon. We're going to break it up into a square and a triangle. So the square is easy. It's just x squared. So the area of the square part is equal to x squared, which is 16 squared, which is 196, I think. 16 squared, 256, sorry. 256. And the area of this triangle, the area of an equilateral triangle, well, I don't know what it is. There may be some formula, but what we can do is break this up into two triangles. And so you've got the height is, we don't know what the height is yet. We have to kind of work that out. So if this is x, then this is 1/2 x. And using the Pythagorean theorem on that this triangle right here, Pythagorean theorem says that x squared is equal to 1/2 x squared, which is this side, plus the unknown, which we'll call y squared. So we'll call this height y squared. So we get y squared is equal to x squared minus, let's multiply that, you get 1/4 x squared. So we get 3/4 x squared. Take the square root. Y is equal to square root of 3/2 times x. Take the square root of each term. You might remember this, the square root of 3 over 2x. So y is equal to the square root of 3 over 2x. So the area of the triangle, the big triangle, is going to be 2, because we have 2 of those, times 1/2 times the base, which is x over 2, times the height, which is the square root of 3 over 2x. So 2 triangles, 1, 2. The area of each triangle is 1/2 the base. Base is 1/2 x times the height, which is the square root of 3 over 2x. So these cancel out, and we get the square root of 3 over 4. 2 times 2 is 4, x squared. So that's the area of the triangle. So the total area of the pentagon, the area of the pentagon, is going to be the area of the square, which is 256, plus square root of 3 over 4 times x, which is 16 squared. So we get 256 plus square root of 3 divided by 4 times 16 squared. That's 366. Or, if we wanted to simplify this, the book actually shows that it's 256 plus, well, we have, what we'd have is 16. If we took this, it would be 4 times 4 times 4 times 4, because 16 is 4 times 4. We cancel out one of those, so that would be, we'd end up 4 times 4 times 4 left over, which is 64. So we'd have 64 times the square root of 3, which is the answer. So that's the area of the pentagon. Okay, I gotta turn this thing off.